Have you seen a lot of 3D printing videos out there, but you don't know if it's a good fit for your shop? Maybe you do like welding or sheet metal or metal casting, or you restore cars, or you make furniture or clothing, I don't know. Why use 3D printing? Well, I'm going to show you a few use cases for 3D printing, specifically FDM printing, the one with the spools of plastic line, not the liquid toxic goo. And then we're going to go over why you might want to consider this particular one for your shop. This is a new one called the Elegoo Centuari Carbon. And my promise to you is that this video will include no 3D printed plastic trinkets for the sake of printing trinkets. Only all practical shop stuff. I do print lots of plastic trinkets also, but that's probably not why you're watching this channel. FDM stands for Fused Deposition Modeling. You don't have to remember that. It uses this plastic line. You'll see spools like that. You know, here's some more up here. It runs it into here and melts them out an extruder into a 3D shape. It goes layer by layer until you have built up a whole thing. Coming out of the nozzle there, think like a MIG welder or a hot glue gun mixed with a CNC machine, and you're most of the way there. Okay, that's cool, but what can you do with that? Well, look around in your day-to-day life. Do you see anything made out of plastic? I'm using the term plastic very loosely here. I'm going to show you some examples, and I'm going to organize it by the types of plastic you will see, starting with the most common. PLA, standard of 3D printing. It's polylactic acid. There's some right there. It's made out of corn. It's very easy to print. It's cheap. It comes in a billion different colors, including transparent and glow in the dark. Some of it's got sawdust in it for some reason. It's probably the most common plastic you see printing. You can print it indoors in a room, and you can be in there, and it's not going to poison you. I have a bunch of printers in my basement running PLA, only PLA. All this other stuff, which we'll get to in a minute, I print out here in the garage where I don't live. It has a reputation for being kind of brittle and weak, and it can't handle really, really high temperatures. Let's stop right there for a second. Weak is relative. Here's a shot of some bead roller dies made from PLA bending 16 gauge sheet metal. These are not solid plastic, just a few layers with a 15% infill. 0% is hollow, 100% is solid. 15% is 15% of like a plastic lattice structure. These won't last as long as hardened steel ones, obviously, but each one is like $1 worth of plastic. If they wear out, print another one. I also use 3D printing for these shelf brackets, and you can hang other stuff on them too. Granted, these aren't heavy shelves. I mean, they're not empty, but plain PLA is more than strong enough. I do reinforce it with a screw through the cleat part, but I don't really know if that's necessary. And I got tons of them all over the place. Here's some woodworking guides. This one's for cross-cutting, like a 1x4 or a 2x4. Little screws to bolt it onto the bench. I designed and 3D printed this. Here's one for drilling. Say you have two 1x4s, line up at 90 degrees. You want to pre-drill your holes either in this direction or that direction. That's what this one's for. 90-degree clamp guides, also 3D printed. I didn't design these ones though. You can probably find designs for pocket hole jigs and all sorts of jigs and fixtures and stuff. Here's some sand casting patterns, 3D printed. There's a small match plate, and these were cast from that. There's a pattern for my sign that you see in a bunch of shots. That one's FDM. These are resin printed, but the FDM ones work the same. Here's a set of FDM ones for the same pattern. And since we're standing over here, pegboard hooks. These were all FDM printed. You have as many as you want. There's a bunch of different designs you can find to print like boxes and anything you want really. Oh yeah, and that car back there. This car is a dance competition prop that I made last year for a local studio. It's for girls. It's doing the Grease Lightning. Look, Grease Lightning car, like from the movie with John Travolta and all of the hair being slicked back. They won every competition. They even won grand champion at a nationals competition for 11 and under, small group, large group, whatever it was. There's a Power Wheels under there. You can drive around and everything. There's a lot of like Bondo and epoxy and paint and stuff, but it's all PLA under there, except for the headlight lenses. Those are resin. And look what finished while I was blabbering on. This is a 3D printed, a 3D scanned mask. So this is scanned to a fitment of my face. It's got the respirator filters and everything. I'm working on this. In the past, this would take a day or two. I think this print took a little under 8 hours. So I could do a couple of these in a day and make adjustments. Here's one I printed earlier in red. You can just crank these out. Had an issue there. That was from the model, the 3D model. Printed it out, saw the problem, fixed the model, went to print it out again. Accidentally clicked to print the original model. Whoops. But now we can like test fit, which is kind of cool. There's room back here for seals and stuff. It kind of fits. It's not very flexible in PLA. Oh yeah, and speaking of 3D scanning, if you have a 3D scanner, you can do some other cool stuff. I 3D scanned my wife and printed a full-size torso It's not weird. She wanted a dress form, a perfect dress form fit to her. Do you know what a good quality dress form costs? More than a printer, as it turns out. And that's not even for a custom scanned one. Any printer that can do PLA can also do PVB, like polycast. I bring it up here because I've used it for investment casting. I've done a bit with plaster investment. I know some people have used it for ceramic shell investment. It's cool stuff. I think it's an underutilized use of FDM printing. Now, there are downsides to PLA. It's supposedly not very strong and it can't handle heat. By not heat, I mean if you leave this in a hot car in July in the sun, it will sag and warp. This is where things get interesting. There are other plastics that are designed to handle the heat a little bit better. PETG is one, so is ABS. Lots of plastic injection molded stuff is ABS. Elegoo, for one, that's a good example. But instead of ABS, I use a lot of ASA. Think of it like ABS, but better at handling the sun, ultraviolet rays. Here are some dryer vent flaps that I use at work. We print these out because, you know, dryer vents are on the outside of your house, and those are in the sun. These stand up better than the ones you can buy in the store because they're actually kind of thicker. ASA and ABS is trickier to print. You need a printer that's enclosed, you know, not the big open ones that you see like a Ender 3 or a Prusa Mark IV. This one is enclosed, so good. They also don't all get hot enough, and this one gets more than hot enough. This extruder maxes out at 320 Celsius, which is kind of insanely hot. For the really high temperature stuff, they also recommend you use a cover completely enclosing it. Bingo, no problem. But some of these are even more interesting. Getting up to 320 Celsius means you can do even higher temperature, stronger plastics like nylon. And it has a hardened nozzle. The extruder tip is hardened steel, it's not just brass. So it can do carbon fiber and glass fiber reinforced plastics and glow in the dark and stuff that tends to wreck the normal brass nozzles that come with other printers. The fiber reinforcement doesn't necessarily make them stronger, like from a toughness point of view, but it does make them stiffer and more dimensionally stable. Okay, I said no plastic trinkets, but these little boats exist for a reason. This is a printer benchmark test called a Benchy. It's got a lot of features that are kind of difficult to print. You know, there's text on the bottom, and this is quite an overhang, and there's holes, and there's a nice bridge here, and there's a little post, and there's more holes and more text. And it's a good way to dial in settings on your printer. And if you get a perfect Benchy, that doesn't mean your settings are flawless, but you know, if you get a good one, you're most of the way there. And it comes pre-installed on the flash drive. A lot of this stuff too, if you're wondering about settings, it gives you temperature ranges on the side of the spool. I just shot for the middle of that range, and that seemed to work right out of the box. The slicer that this comes with, though, has some pre-made profiles for Elegoo filament. So if you just want to buy Elegoo filament and stick it in there and use Elegoo slicer, which comes with it, then it's kind of it's a little more of a plug and play thing, but I always like to screw around with different stuff. Okay, here's a strength comparison for you. 2 blocks printed with 2 wall layers and I think 10% infill, I don't remember. Red one is PLA, the other one is called PPA-CF. It's a carbon fiber reinforced nylon. Running them over with my wife's car a few times caused some PLA damage, but nothing to the nylon block. My work truck, which is a lot bigger, caused more damage to the PLA block. It still didn't do anything to the nylon, despite running it over probably a dozen more times. I was waiting for that crack, it never happened. You can see how thin the walls were on this PLA thing. This was not solid, it was mostly empty. And this is the shape of that infill. It did not handle the truck well, let me tell you. The other one, no problem. I mean, there's a tire print on there now, but otherwise zero issue. And this is, like I said, these are pretty hollow. I think these are each like 150 grams or so, very light. And it's not just crush strength. Like check it out, here's a handle, very thin handle made from that PLA. One hand, see? I'm not the Hulk, and that did not handle it well. Pun not intended. Well, yes, it was. And here's the same thing in, I think this is PPA-CF. Fun fact, gloves, these carbon fiber and glass fiber filaments, if you're going to be touching it a lot, you'll want to use rubber gloves or a clear coat. Just spray it with a clear coat, that'll help. Otherwise you get all itchy. Okay, and drum roll. Both hands, both hands. All right, well, I know everyone loves the display of my weakness as much as the next guy, but these are really strong. This might be a bad idea. Let's see. Workbench, heavy vise. Oh, these are too small to get my fingers in. What idiot designed these? It was me. Okay, let's see. I heard a crack. I heard a pop. Oh, the layer cracked. And that's only that thick. That's pretty tiny. It's pretty strong. And if this stuff is that strong, and you need over 300 Celsius to print the stuff, you can probably make some pretty awesome things with this. I think the marketing for this stuff has like drone frames on it and other like gears and whatever. And that makes sense. You know, drones, they crash a lot and you don't want to be made out of glass. Also, if you look at an engine bay of a car, like I think engines are pretty hot, but a lot of cars these days have plastic intake manifolds and a whole bunch of other parts in there, like housings and stuff. It just goes to show plastic's not as crappy as people think it is. And obviously this isn't big enough for an intake manifold, but you could print housings and ductwork and all that kind of stuff in this material and actually use it. And not just for prototyping, but for an actual final custom product for use in high temperature, high impact kinds of settings. It's pretty cool. Now that being said, I did have one problem. This hose here is where the filament goes through. And as the head moves around, it can get bent pretty sharply. And there's a sharp bend up here. And some of these filaments are quite brittle. Not this one, not 90% of the filaments, this isn't going to be a problem. But specifically the PETCF would break in that hose and you would get a couple of cracks here. That's an issue. I have a solution. I printed this on this printer with this filament. It's split up into 4 pieces down the lines here. I printed it with this edge on the build plate. So that means this part sitting on here, this part sitting on here, and so on across this edge. It's got a hole in the top, a shelf for a filament dryer, which we'll talk about in a minute. And underneath, I just lined the whole thing in aluminum foil tape. That's how it's held together. Also some super glue. My idea with the aluminum foil tape is it helps reflect and keep the heat in. That was the end of my thought process. I did 0 testing on that. And here's how it works. We can disconnect that, kind of slide it out of the way, slide another hose down in here. I happen to have one of these sitting around. It's PTFE tube, it's not hard to find. Push that, thread this up through the center hole on the top. You can set a filament dryer up here. This filament dryer has its own PTF whatever tube that pokes in there, and you can put your filament in there and then run it up through here. So you can actively dry it while it's printing out. Feed this in. Feed that through there, and eventually it will feed through there into the extruder. What this means is while this head is moving around, this never bends a significant amount. It's kind of just straight down, because as it moves around, it just pushes this in and out of the top. Most of the filaments that I like to use will absorb moisture from the atmosphere, screw everything up. You really need a dryer, or they're brittle, like this one, or both. You have both problems. This setup fixes both issues. And I'm gonna take the files for this and I'm gonna upload them so you can just click down below, download it, and print your own if you get one of these. And the extra PTFE tube, I just had laying around, but you could probably find one of those as well. And then there's the even cooler stuff. I probably should have mentioned this earlier. This is called TPU. It's actually flexi, see? It's like rubber. This is 85A, this is 95A. So this is squidgy clear and slightly less squidgy black. It's still kind of flexible, you know? Hard to see black on camera. You can make a lot of cool stuff with TPU. Like here's a rubber tire for something. Here's a strap that I printed that turned out to be way too thick. Here's the stiffer TPU, the stiffer black stuff, but it's still quite floppy. And people I've seen make gaskets. So these are like custom gaskets for whatever you want. I don't know if it would last quite as long as silicone, but I mean, it does work. I printed some other straps. We're going to try to connect these up on this mask thing. And I made these little posts to go through, lock them together. The first set of these were way too thick, way too stiff, even though it's supposed to be pliable. And I have all the little slots in there because I don't actually know how long this has to be. This is kind of the neat thing with 3D printing. With all 3D printing, you can kind of prototype things. And this TPU, this is, I think it's Ceratec 85A clear. Supposedly it's biocompatible, which means if you have this strap touching your skin for days on end, it's not going to irritate you, which is kind of cool. And they're stretchy too. If I was thinking, I probably would have just printed the whole mask in this, and then it would be flexy enough to fit around my face. Got to leave something for the next video though. Let's see, that one right there. It kind of works. Oh, now it's stuck on my head. Hold on. Okay, work in progress. Okay, so if you want to print tough plastic or any of the stuff I showed here, this is a pretty good printer for the job. I do have a couple complaints. The one is the brittle filament breaking in the line. That's easy to fix if you use this thing. Again, free file down below. The second issue is the size. So this is a 256 millimeter cube. So the build area, anything within a 256 millimeter cube, you can print. It's not big enough. I know that's bigger than a lot of desktop printers. It's bigger than an Ender 3 or a Prusa Mark IV. But you know, I always need a bigger one. Maybe not car sized like the one over there. I actually did the math on this, and I would stop complaining so much if the printer could print a cube that was 600 millimeters on the side. I'll go as low as 575. I've done the math. Of course, I can use a bigger one, but everything that I have in my mind for potential projects fits within that size cube. So that's a target. If you can get all the features of this thing 2.5 times bigger, I'm sold. Second issue, though slightly less important, is a multi-material kind of thing. I know a lot of printers use multiple materials, so they'll have multiple rolls of filament, and they can mix and give you different colors. That's neat. I really don't care. I want to be able to mix types of materials. So if I could do like rigid carbon fiber stuff with nylon to make it like a compliant, like a part with mixed hard and compliant parts, that would be fantastic. I can think of a lot of uses for that. Maybe add another one so you can get like dissolvable supports or something. There's a lot of options. Also, for the record, I did try printing a filament full of wood pulp or wood, whatever. This is maple. It smelled like a wood shop when I was printing. It plugged the whole works up. This is a discount wood filament, wood-filled filament. So if this interests you, cool, keep an eye out for it. They haven't quite released this, although there is a link down below to their website. When they release like an order form or something, I'll put links to that down below instead. And if you're interested in sand casting, there's another link down below for you for that as well. See you later.